Um, Thank you all for joining us today. Just wanted to make sure that in acknowledging the traditional lands that we're meeting on today, which is the traditional lands of the Ghana people, specifically Tandanya, the place of the dreaming red kangaroo. And of course, I only know a few words in Ghana language, so I hope to be able to increase that. But I think a very quick one to be able to get our heads around is hello, or how are you, Ninamani. And of course, hopefully all of you are doing good, and then you can reply, Marnie, I'm good. But in acknowledging Ghana lands and paying respects to elders past and present, we also want to continue to acknowledge the legacy of Tandanya as a meeting place, a place of sharing knowledge, sharing perspective, stories, inspiration, all of that. I know that this particular place has always been a spot for not only Ghana, but Ngarrindjeri, Pamarank, Nukunu, and Nadjeri people as the immediate neighbors of the Ghana, where they've traded not only objects and items, but also knowledge. And hopefully we can continue to emulate a bit of that ethic, as well as a collaborative approach to sharing knowledge through the things that the Adelaide Sustainable Building Network does as well. But for those that aren't aware of who I am, sorry, I was about to say happen to be. My name is Ken Long. It's a very bad habit that I just assume that if you come to ASBN things, you might know who I am, just because I've been doing it probably a little bit longer than I anticipated the first time I took up this position. But my name is Ken Long. I'm the chair of the Adelaide Sustainable Building Network. We are always very honored to be able to host events like the one we're having today, which is all around pathways towards regeneration. And something around the ASBN is that as we've sort of matured as an organization, and of course being a little bit more strategic, we've begun to try to create event themes, like thematic streams through our events, and especially themes that very much resonate in the current development, design, construction industry. And for this year and the next couple of years, what we've identified as very strong themes are net zero, net decarbonization, and pathways towards net zero. We also have a stream that's all around circular economy, things around materials, as well as the continued elevation of not only recycling of materials, but also keeping value in materials and also processes and services that we create here in South Australia. And one that I don't think I'm speaking out of term, but the ASBN committee is all very passionate about is regeneration, especially regeneration of our natural ecologies. In the steering committee, we have people that work all across various realms of the built environment or connected into our communities. But one thing that we're all very much passionate about is driving environmentally positive sort of outcomes. So being able to host a discussion that's focused on regenerative our natural ecologies is very much close to heart. So thank you very much for sharing time with us on that. So for our session today, we will be starting off with some presentations from some fantastic people, and very hand-selected, right? These people aren't the ones that you just say, hey, you look like you do some interesting stuff, we're just gonna pull you in. These are specifically curated to stimulate your minds. And they're going to stimulate our minds with some fantastic presentations. And then after our presentations, we'll have a chance to talk to each other, maybe have a glass of wine or non-alcoholic beverage called water, or that was supposed to be a joke, obviously didn't land. And but also more importantly, to nourish your body. So of course, make sure you stay around for the nibbles. And then afterwards, we're going to have a nice yarn. So the way that we want to make sure that you leave here with is, well, one, you got some information, you're inspired, you've met a couple of people, and you feel fulfilled, mind, body, and soul. Sounds good? Sounds like an experience you would like to repeat every month, right? I take that as a yeah. So just keep that in mind for 2024. We do these things monthly. So are we ready to be inspired? Yeah. I definitely am, and I've been looking forward to this very much so. So our first presenter of the day is Sam Corner. Sam, right over here. So I reached out to Sam mainly because of this fascinating science around, qualitative science around the connection of the health of the environment to the health of our human being. I know a lot of people talk about that in potentially sort of like a, not theoretical, but almost like a philosophical way. But this is the science that really underpins that. And invited Sam to kind of talk to us about what that is, but also how that might apply to us in urban environments. So he'll take it away from there, and I'll just fire it up and let you go.
Hello, everyone. Thanks, Ken and ASBN, for having me along. I'm going to try not to talk all night because I have a habit of that pretty well. Arrows all good. Just going to jump straight into it. I don't know, probably a lot of you might have trouble reading some of these words on here, but I'll just talk it out. We're just going to have a quick whip through. I'm going to try and stay on time for Ken, but see what happens. So I don't know if anyone read my blurb, but basically had a background in a bit of all sorts and had some health issues myself about 5 or 6 years ago, and basically got nowhere in life, and I started looking to try and find out what's the actual deeper sort of controlling parts of our bodies, and started quickly learning that our gut biome and our stomach's our second brain. It's a very important thing to regulate us and help us through our life. And then it was like, well, how do we help our gut biome, and where does that come from? And then these linkages started coming back into the environment and everything around us, essentially. So we're going to have a look at a whole bunch. I'm going to really quickly go on about human health and then more about biology, and trying to pitch into where it can sort of fit into this space. But I'm around after. Please come and quiz me with any questions or anything you want to know, or I've got my information in there to reach out to me later. So feel free to reach out at any stage. So pretty much the human gut, and we call it the small intestine mainly, which is pretty much the main worker of our body. It's, 30 to 400 trillion microbes in there. So when we think about a microbe, it's a nanometer potentially, but we're talking about 30 to 400 trillion. And the reason that range is so big is because some of us are healthy and some of us are not so healthy. So healthy person's going to have a lot more than an unhealthy person, but also on the flip side, if you're unhealthy and you've got an overgrowth of a form, you can actually also have a lot. So stacks of microbes in there. There's more microbes in there. Basically, as it says, 300 to 100 times more bacteria in the gut than cells in the entire body. So when we're talking about that, there's a lot of stuff going on in there. The microbiome, you've probably heard a lot of, that's basically our makeup of our biology that's within us. And that can be the types of bacteria or the types of sometimes fungal presence. It's not so great, but it's just how the organisms are, how they interact with each other. How do we get the microbe in us? We get it from our mother, actually, in our womb. She starts it. We're quite sterile in there, but it's then started more from the delivery method of birth. And this is, I'll try and keep on a positive note, but the difference of like a C-section versus a natural birth is a massive difference in your makeup from your gut biome as you basically live your life. So obviously natural birth, you're actually getting fluorinated with your mother's microbiome when you're actually coming out as well. So versus a C-section, it's a very sterile type delivery. So sterile means you don't have your own microbiome until later on, which is basically what comes next. You think about what a baby does or a kid does, it starts touching and puts things in its mouth. That's the population of microbiome that starts to make up the person. The other big thing at the early stage is breast milk. That's a massive thing that actually populates the gut biome as well. And someone said at another quick talk I did about koalas, I don't know if anyone knows the story, the mother actually does some interesting things to them before they can actually process gum leaves. So they eat the feces basically to populate their gut biome to actually be able to cope with gum leaves. So it's quite a transition, but unfortunately many of us and many children born now are not getting a great gut biome to start with. So it's pretty well believed that 80% of our immunity comes from our gut biome, and that's why I think there's a lot of problems that a lot of us have had. So what are some big things that affect it? And this is not going to come as a surprise, and biodiversity and diversity is going to be a word I'm going to talk about tonight, and I think it's a bit of a theme, and it should be a theme in everyone's mind, and it's no different for our stomach. So basically we've got a diversity of organisms in there. We need a diversity of food to feed those. We can't just eat rice all the time and expect to have a diversity of organisms. It doesn't work like that. So we need to basically not have a monoculture diet, try and avoid any processed food, chlorinated water. If we think about what chlorine does to water, it's obviously killing biology in there. We put chlorinated water in us, it's killing our biology inside us. It's no different when we're under the shower, chlorinated shower, we're killing biology all over us as well. So there's quite a big link there. Medications, I probably don't need to talk about that too much, but obviously a lot of medications that we put into us, antibiotics is a typical one. Antibiotics is going in us to kill bacteria essentially, and it doesn't just kill the type of bacteria you want, it kills all bacteria. So when you put that into your stomach on a frequent basis, you're basically wiping your slate clean in there, and then you've got to repopulate it. And that goes well most of the time, but sometimes it doesn't. Stress and anxiety, I can attest to that I think that's what set my whole health problems off over many years, and that's probably the biggest one for most of us, maintaining that adrenaline rush, that actually the adrenaline and the cortisol reaction kills a lot of our biology in us as well. Feedlot raised meat, it's probably a big topic for a lot of people, but feedlot raised meat is not good for us, and that's from a lot of ways, but mainly from the hormones and glyphosate-fed food, vitamin B3 over B6 imbalance. There's lots of things there that you can research into, and there's also a lot of antibiotics resistance from that, and that all ends up in us. So think about that. We'll talk about some positive stuff in a minute, but why do we continue to have a lot of gut problems? Because we are what we eat, and it's right now, it's known right now that it's the third largest category of illness, and I think as we go forward in the years, it's going to become a much greater actual observed problem with that. Every problem that most of us have right now or will have probably has some linkage to our gut biome and our immunity, and I think we're going to learn that as we go forward more in life. So what can we do? Prebiotics, probiotics, and that's not in the form of capsule or milk. That can actually be from plants as well, which I'll touch on really quickly. But plants should have organisms on the surfaces. Those organisms are actually prebiotics for our gut. That's where we get a lot of our fluorination from as we go forward. Don't be scared about getting our hands dirty. This is how we basically touch and feel, and we get microbes on here. If we're too sterilised all the time, our body will become hypersensitive to any microbe that we come in contact with, and hence why a lot of our younger kids now have a lot of allergy sensitivities, because basically they haven't actually had any of these sort of germs to build their immunity against. They basically are very sterile from their gut, and then we clean everything in the house, we sanitize all the time, and then all it takes is a reasonably aggressive type of bacteria or any other sort of organism to come in, and then our body basically immediately just goes back and fights at it, and that's obviously quite an obvious immune reaction, which we're seeing in so many people now in the form of inflammation, which I don't know if everyone here has suffered inflammation before or you know it yet, but you probably are. So open your windows, get outdoors. I said have as much diversity of food, as many colours on your plate as possible. That's a big thing that people talk about, just to get that diversity of food in. Obviously, organically grown food or food that's not grown with pesticides or any synthetic inputs is really good. More raw food, the better. Every time we cook food, like good and bad microbes die above 77 degrees or even 65 or a longer duration time. So the more raw food we can get, we're actually getting biology into us, which can help our culture and make up our biome as we go along. And it also feeds other biology in there in a good way. So filtered water and fecal transplants, if anyone wants to give that a go. It's a massively big thing going at the moment. If anyone knows what that is, but basically you pay someone for their poo and then you get it inserted into your colon, and you basically inherit their biology or their biome. And that's a massive thing, fixing like chronic illness and conditions now. There's people all over the world that, I don't know, like MS and things like that, cured overnight from that basically. So you'll see that go forward. The thing is the control mechanisms around that. In Australia, it's really tricky to do that at the moment, but we'll see a lot more of these biological sort of substances or capsules and things for sale as we go forward in the future. But obviously that's someone else's biome, not our biome. So it's not the best thing out, but it's probably better if your biome's shot to crap. So literally shot to crap. No pun intended there actually, but we'll go with it. So we go, well, what's the link? I'm talking about stuff and I'm like, well, how has anything in here got anything to do with the soil? And it's like, well, what is that? And it's like, it comes from the plant. It comes in our food. It comes in everything that we eat. And that's when I'm like, wow, I need to get into that. And then I'm like, but how does a plant get its microbiome? Well, where does that come from? And then it's like, it comes from the seed. We think about a plant's no different to a human. When the plant goes to flower and creates a seed, the mother or the plant, host plant, is actually populating that seed with the biology that the plant needs to grow forward and go into life. There's obviously lots of organisms that will come in the ground to support that, but its indigenous organisms or its indigenous microbes are in the seed. And obviously, if anyone knows about agriculture, a lot of our seeds aren't quite so natural in their sense anymore, which we'll talk about. So how are we going for time, Ken? 10 minutes, that's good, we'll be right. So some big groups, everyone knows about bacteria, I think we know, and I don't know if anyone knows bacteria can be good as well as bad. I'm not sure, it's probably got a pretty bad rap. Obviously the bacteria in our stomach or our gut is very different to the bacteria that should be in the ground. Our stomach's a very closed environment. It's very anaerobic. The bacteria types, the bacillus strains and things like that, whereas our soil should be open, friable and aerated. So we stick to more to the cocci type varieties. But obviously we've definitely got some pathogenic bacteria that lives in our soil and in our stomachs as well. They're single-celled organisms. You can look at them under a microscope. They're pretty hard. They're about 1 to 5 micrometers, so 500,000 fit on a pinhead. So you can sort of get an idea of how small they are. They eat really simple foods, and bacteria are very easy to feed. Simple foods, I mean like sugars, carbohydrates, plant exudates. So a lot of these actually feed from sunlight conversion, and the roots actually push out the food for these biology, and they consume that. They're not good at breaking down complicated plant material or larger strained acids or chemical compounds as such. They're not so good at that. There's obviously millions and millions of species that we know of now, and that's just what we know of now. I don't think we can fool ourselves that there's probably billions of species of bacteria out there. Most soils are dominated by bacteria, which we'll talk about more in a minute. Fungi or fungi, whichever country you're from, my favourite thing, nearly my favourite thing actually, but something that really cops a bad rap as well, because fungi obviously gets talked about being pathogenic a lot of the time as well, which is very rare to be pathogenic compared to beneficial. Fungi it's something that I can't not harp on, that it's one of the most important things that we need to look after going forward. They can be 1 to 10 microns wide, but they can be kilometres long. The largest living fungi is in America somewhere. It's like 500 and something kilometres long that they've tracked. So, and these are living deep in the ground. So they're amazing things. They consume complex foods, plant matters, break down a lot of chemicals, humic acids, for those who know, like fish hydrolysate, a lot of these interesting, complicated foods, these guys break it down. What else do? They sequester and hold carbon into stable humus. Massively important for that, and this is why they are so very important. The sad thing is that through current industrial agriculture methods, these guys take the biggest beating out of everything. It's estimated at the moment that there's about just shy of 500 gigatons of carbon that's been released from our soils, and that's more than any other form of carbon releasement, even fossil fuels, and that's all come from us destroying fungi, which I'll touch on in a minute. So fungi have a massive place to play in sequestering carbon and restoring soil health and everything. So mycorrhizal fungi is something probably a lot of you may have heard of. That's a type of fungi that pretty much it binds onto living plants, and then it goes over longer distances and creates a network that can exchange nutrients and health. So you might see a tree that you've cut off, at the base, and you go, how is that tree reshooting? Like, how does that tree get photosynthesis and nutrients? It's actually not doing it itself. It's supported by other trees. Generally, its mother or its family of trees connected via a fungal network. So the fungi plays a massive part in keeping our ecosystems and our biodiverse ecosystems healthy. They struggle when we get into monoculture type environments because they like looking for all sorts of things to feed to all sorts of plants. And they're vital for carbon sequestration, holding that in humus colloids. So, protozoas, these guys just get missed all the time as well, or protists. Actually reading a thing the other day, the guy first discovered these in 1600 when he made a lens. I cannot remember the guy in a lake, and he found them. These are a little bit bigger. These guys eat bacteria galore. They eat about 10,000 bacteria a day per single organism, and that's like crazy amounts. These guys in a natural system, and I'm going to show you how these all connect up in a minute. These guys are so important for the conversion of nitrogen naturally, and a lot of soils I look at in agricultural, these are all gone. Pretty much there's nothing left. Hugely important. We know 60,000 species, but I think we're just learning as well. Nematodes, another thing that gets a bad rap as well, but as you'll see, there's 4 plus quite a few more, and root feeders get the biggest, root knot nematodes get the biggest rap, but they're such a small representative portion of this. So nematodes are like a small little worm. They can be up to 1 millimetre long, but generally normally about 50 to 100 microns. And they can be bacterial feeders, so they feed on bacteria. Fungi, they feed on themselves, and they can also be switches, so they can feed on one type of food, and then when the conditions dry up, they actually convert and start feeding on something else. So it's pretty common to see a bacterial feeder, which can then switch to be a root feeder under the right conditions. So it's pretty tricky to keep up with them, but these guys are really important for nutrient cycling as well. Arthropods, and this is probably, we're getting to the point where we can actually physically see stuff now, and arthropods are a hugely important organism, and they are like our shredders. So they start to break up bigger organic matter, but they also consume fungi as well, bacteria, a lot of different things. They can, slaters are a type, but there's a lot of microarthropods that are so microscopic, like you can see the one on here, that are busy in the soil. And the other big thing that they're used for is they're transporters. So I look at these under a microscope, and you actually see bacteria jumping on, clinging on the back, and then the arthropods actually cruising around. So they're a taxi cab. Oh crap, better get on with it. Running out of time. Earthworms. Earthworms are super amazingly important. Earthworms are, for an aeration point of view, they really help us to get down, break up the soil, get air pathways in. Like them as well, they're also taxi cabs for other biology that jumps on their mucus and actually gets transported. Super important for nutrient cycling, breaking down carbon matter. They eat protozoa galore. Generally, if you've got no earthworms, you've probably got no protozoa. That's a big thing. If you put protozoa back, earthworms just appear out of nowhere. So it's pretty cool. They're not compost or red wiggler worms. There's very different, and a lot of people sort of coming to this realization now. Earthworms obviously live in the soil. They don't need to be fed on like organic matter permanently. They can actually eat other organisms. There's many types, and a lot of them are horizontal deep layer, horizontal shallow layer. There's vertical type earthworms as well, and they all interact to create tunnels and burrows and nutrient cycle. So how do they all connect? It's called the soil food web, and this is my passion that I've been studying for quite a while, and it sort of starts to put some sense around what's needed where to eat what to cycle a nutrient. And pretty much it starts with the plant, goes through biology to animals, and then it comes to us, or the plant comes straight to us in some sense as well. But this just shows that if we have a dominance of one and we have none of the other, our nutrient cycling is not actually becoming plant available, or it's not actually, it's not performing the function of the soil to aerate it, to hold oxygen in there. The soil can change conditions. So it's not storing carbon through humus retention or anything. So there's a lot of things that's very important. I could talk about this for ages, definitely. If you want to know more about this, hit me up. But super important how all of these things interact. And this is just a biodiverse environment where these things connect, and it's super, super important. Another quick thing to talk about is plant succession, and this is something I just probably more relation to this group and how we make gardens, or how we can make grounds around our buildings and things like that. Obviously, the higher successional variety we go, the larger the plants, the shrubs, the bushes, the trees, they generally will have a fungal dominated soil, generally, as they're healthy. Whereas if we've got weeds popping up everywhere, it's pretty much full bacteria and nothing else. So through our gardens, the diversity, especially with a lot more established larger bushes, help us get to that fungal dominant side, which helps us sequester carbon, and it helps our happy life with everything going forward. So the fungal to bacterial ratio, they call it, is becoming quite a big thing now, and you'll hear about it talked lots and lots, and there's meters out now and all sorts of things that people do. But in cropping and things, they're like, oh, we need to figure that out, because pretty much most broadacre cropping that I've ever looked at in South Australia has got no fungi left in it. And that's where these people are trying to put that back through mechanisms now, and they're getting that scale moved up, their weed pressure's going down, their plants are nutrient cycling more naturally. It's all good. Caring, that's the last slide, I hope. Pretty much one of the massively important things is organic matter. So if we're doing gardens or raised areas, is getting a good level of organic matter in there, and that's like 5% plus. Like anything below that, trace minerals and biology will struggle to survive in there. So 3.5% is like the internationally accepted minimum. Most of our farm soils I've ever looked at here, about 0.5 to 1% now. So we're well below this, and we wonder why we've got problems. Avoid monocultures where you can. So don't have the same tree everywhere, don't have the same bush everywhere. Mix and match, have diversity. That's super important for diversity of microbes, which supports the diversity of like healthy soil. Try not to use chemicals where you can. The even better thing is don't get seeds that are chemically treated, especially fungicide treated seeds, because the fungicide is not selective. It kills any fungi that tries to grow from that seed from birth or when you're putting it in the ground. So it's not ideal. So try and get away from that. Synthetic fertilizers, generally not a good idea if you can avoid that. Little stat I've got here, 1 kilo of synthetic nitrogen we put off burns off 100 kilograms of carbon. So if you can think about that, what we're doing, and the 1 kilo of nitrogen, you're actually plants picking up about 30% of that now. It's dropping down at a rapid rate. We're losing from applying synthetic fertilizers about 7 to 10 tonnes of topsoil per hectare a year. And pretty much the international consensus is we've got about 60 years left of fertile topsoil if we don't change our agriculture ways. So sorry to put a downer and everything, but we need to bring attention to this. And there are a lot of people changing their ways because they can see this and they know. So don't take this as no one's doing anything. There are a lot of people realising this and changing the direction of this. But there's some pretty scary numbers there that we need to really figure out. Soil biology in itself and plants and diversity can fix our carbon emissions and our carbon levels in our oceans and our air like quite easily, hands down on their own without doing anything else. We pretty much need to get 0.5% organic carbon in the soil in all our agricultural lands in the world, and we're back to like pre-1950 levels of carbon. Not a big task. That's not a thing. People do that in 1 year easily, so it's not a big task to do. Avoid bare ground. Bare fallow is the worst thing. Plants, photosynthesis, the roots feed biology, so bareness, nothing's getting fed in the ground. The biology dies when there's bareness. Minimise tillage to ploughing. Every time we plough, we're breaking up those fungal networks. We're killing fungi as well. So try not to till. So people might have heard no-till gardening or minimal till. direct seeding, you know, all of these things, to sort of ask questions if someone's doing planting for you. I probably should stop talking now. Yeah, wrap it up, he says. Animals are great. Avoid chlorinated water. If you can filter your garden water, that's a massive thing you can do straight away to actually help with that. And assist biology at planting by helping the organic matter, getting extracts and all sorts of things. And there we are at the end. So that's me. Thanks, mate. Cheers.
And then, as I mentioned, we're getting all the inspiration before we get into a little bit more of a yarn of what all of this bits of meaning. But Sam, really appreciate sort of like setting the scene, because I think, especially getting back to quite literally the roots, so to speak, but understanding what does a lot of our activities, whether to regenerate our ecology, that's what it's in service to, the whole cycle, the whole cyclical bit. And we have to really understand what systems that we're actually really a part of to do that. And hopefully our landscapes that we design and that we cultivate and maintain, they can kind of do the same, especially, which I was hoping this link would happen, was kind of underpinning a lot of the work that our next presenter will be looking at too, as if we get these systems correct, then hopefully we'll be able to make sure that even landscapes, whether they're rural for agriculture or even for near human habitation, can really help with biodiversity. But I really appreciate that our next presenter has joined us all the way from Melbourne, even though it did coincide with a visit to South Australia. So jumped on that train really quick. I was like, hey, Ash, I know you're doing some amazing stuff in the realm of nature, not only nature conservation, but also looking at, I guess, sort of like nature economics or things of that nature, things of nature economics in this way that we're moving toward economic activity that helps support the regeneration of our natural systems. So please welcome Ash Knopp, CEO of Wilderlands, and I'll get this fired up and you can take it from there. Let's make sure, I know Ash is from Melbourne, but make sure that he feels welcome, please.
I did spend a year at Unley High for my sins back in the 90s, and I've got family in Mount Barker, so I'm partially South Australian. Lovely to meet you all. Thanks for having me. As Ken mentioned, co-founder and CEO of Wilderlands, and thank you, Sam, for, setting the foundations. Also want to acknowledge the traditional owners, the Kaurna people on which we meet, and the Ngarrindjeri people who we partner with in one of our projects. So imagine if you could pick a square metre of vulnerable Australian land and protect it forever. You could learn about its unique flora and fauna. You could receive regular updates from work that's going on the ground. You could watch as nature flourishes thanks to your support. This is what we do at Wilderlands. Wilderlands have developed one of the world's first voluntary biodiversity credits. I'll explain a bit about what that means and then talk about why it's relevant to an audience from the built environment sector. So our credit, known as the Biological Diversity Unit, represents 1 square metre of permanently protected, actively managed vulnerable habitat. Like all credits, whether it's in carbon or biodiversity, we've created a standard known as a methodology. Our proprietary methodology is predicated on a number of core things, and that is the projects that we engage with are all permanently protected through conservation covenants. Quick hand up if you are aware of conservation covenants, if you have an understanding of those. Okay, that's good, helpful to know. So in most states in Australia, if you have if your privately held land is of high ecological value, and if you so choose, you can place what's known as a conservation covenant on that land. It needs to be assessed as high ecological value, worth, I guess, the investment and protection. But by placing a covenant on that land, you are now legally bound to manage it for nature outcomes. A whole bunch of things you're not allowed to do: develop on it, clear it, motorcycles, that kind of thing. Whole bunch of things you must do to maintain its integrity. And the state effectively manages through monitoring that you're legally doing that. That covenant sits on title. So you sell that to the next owner, they then are obligated to meet those obligations, and on and on and on. So they're a great thing, but they also obviously come with requirement and a level of understanding and skill of how to manage these properties for nature outcomes. So that's a core component of our projects. Another one is the ongoing active management of these projects by skilled and experienced conservation organisations. These are projects on privately held land, often buttressed up against agricultural land that might be cleared for other purposes. And so it's very important that once again, skilled and experienced conservation organisations manage whether they're grasslands or wetlands or woodlands, whatever they may be, for nature outcomes. Pest and weed infestation, if left alone, will destroy these threatened ecosystems, because most of our threatened ecosystems are on privately held land in Australia. So those two core components of permanent protection, active management for 20 years on our project, are critical to our promise and methodology. We then have created technology that effectively creates these 1 square metre units. So through GIS mapping and the like, we take our project plots and we create 1 square metre geotagged units, and those units sit on an independently verified and managed registry, and then once sold, bought by an individual consumer, a business, whomever it might be, the units are effectively retired, so they can't be double spent. And the idea is that the funds that have been raised by the selling of those credits go to help the permanent protection and the active management of these projects. Now, there'll be opportunities for questions a bit later on, and I know I'm throwing a whole bunch of stuff at you that probably is going over the heads, but what's critical to our work is we don't own or manage projects ourselves. We partner with the existing experienced conservation organisations. We launched last year with 4 projects across 3 different states, and our project partner for those 4 projects is an organisation called Cassinia Environmental, a Victorian-based organisation that's been doing land management for both biodiversity, environmental and cultural outcomes for 20 odd years. And we chose with them 4 projects that represented different types of ecosystems, different areas, different regions, different stories. I guess as an expression of what could be. And the intent over time is as demand grows for these credits, or as opportunity grows through partners and the like, we will turn on more projects through more project partners. Since we launched, we've basically been inundated with both private landholders and conservation organisations, small and large, to say, we love what you do, how do we get on your platform? How can we unitise our projects? And it really comes down to demand. As soon as we've got enough demand and momentum, we know that we can fulfil the promise of selling credits to help support ongoing work in new and wonderful areas. So to bring it to life, these are the 4 projects that we've got currently on the platform. Grasslands in north central Victoria, woodlands with supporting threatened birdland communities in New South Wales, tall forests in the Otway Ranges in Victoria, and probably our flagship project, and why I've been here this week, is our project in Coorong, just down near Meningie there. It's a 200 hectare plot of remnant vegetation. It's, when you zoom out, completely surrounded by cleared grazelands. It's a very significant project because it's been co-developed, co-designed and is co-managed by the local traditional owners, the Ngarrindjeri, and those from the Ralcan community who work there. It's a significant project on a number of levels, and it highlights, I guess, what's actually most critical about environmental engagement, and that is that we have intrinsic engagement with that as peoples and our First Nations peoples in particular. We need to be in these environments to help support and maintain them. And so I guess the co-benefits, you'd call them, of environmental engagement is a critical component of the work that we do, and increasingly another kind of credit development that's occurring. I can wax lyrical about these projects all day, but this one, as mentioned, is of particular significance to us. And what we can do, obviously, post this event too, is to share, sorry, there should be some moving imagery there or videos, but is to share some links to some of the work that we do and the projects that we've got as well. So as you can appreciate, this is a very new space. Carbon credits have been around for 20 odd years. Biodiversity credits from a compliance perspective have been around for quite some time. But voluntary biodiversity credits, which are designed for net gain, part of our needing to protect 30% of nature by 2030, our credits can't be used for compliance or offsets in that respect. This is a very new space. And so we've met up with our peers globally. We were at COP15 in Montreal in December, where we met with our peers, and under the UN auspice of the Biodiversity Credit Alliance, we meet very regularly to talk about integrity, transparency, how do we have alignment with what we do. Unlike in carbon, where there's one carbon tonne recognised metric of tradability, when it comes to nature, it's more diverse. And so there's not likely to be one credit that rules them all in the biodiversity space, because it's going to be more, reflective of local conditions, jurisdictions and the like. But it's very important that we have alignment in standards and how we monitor and measure the work that's being done. I'll move on then to, and we've got a fantastic team. We're a very small team of subject matter experts, co-founded by a 6th-generation farmer who's been doing this kind of thing for a long time in terms of work on the ground. And a big part of actually why we developed what we developed is to help incentivise those who want to do the right thing, but are looking at their properties and going, well, I know how much money I can make off that cleared yield agricultural land, but this land over here, as much as it means it's important from a natural perspective, frankly, it's costing me. And so how can I potentially be supported to manage that for nature outcomes? And this is a part of the incentive that we've created, because historically it could be said that you could make money clearing land, you could make money regenerating land, but it was very hard to be rewarded for protecting it in the first place. And this is another, I guess, reason why we've created what we have. Now, why is this relevant from a built environment perspective? I guess there's a couple of things to touch on here, is that we see increasingly, much like in carbon, where businesses these days, it's table stakes to have a net zero aspiration, to measure your impact, to mitigate or minimise and then offset the rest effectively. That also is coming in biodiversity. With frameworks and momentum around legislation and so on, there will be a time in the near future where businesses will be held to account for their direct impact on nature. It's also important that they understand the risks to their business of nature loss. And so much like carbon credits are used in the climate space, we imagine that in time biodiversity credits will play a part in helping businesses to mitigate against that loss. That is a future time. We are a small business. We need to be viable between now and that future time. And so we're actively looking for ways in which we can engage with customers to ensure that we survive until that nature positive time is just part of the zeitgeist and social license to operate. And so one of the things that's come to us very recently out of left field is our neat fit with some of the built environment certification schemes. And I'll quickly touch on that. So hands up for those who are aware of green building tools and community tools and abide by those kind of things. Yeah, so for those who don't, bear with me for a couple of minutes, but in effect, obviously, if you're a developer or a sustainability consultant or an architect or whatnot, and you're looking at either putting in a new high-rise or developing new communities or whatever it might be, you're likely going to be aligning with a certification scheme of sorts. And there are a couple in particular, the Green Building Council's Green Building Tool, as well as the Living Building Challenge's Living Building Challenge, the LFI's Living Building Challenge, whereby we've identified that our credits are a neat fit with particular credit types. And in this case, within the Green Building Council, it's the Nature Stewardship Credit. I'll very quickly explain what that is and then how we fit into it. So in effect, if you are looking to get 5 or 6 stars on your building, you're trying to accrue as many credits as you can accrue 2 credits by sponsoring an off-site conservation project, the equivalent of your footprint, whether it's the gross floor area or GFA or site area, whatever's largest. And by fulfilling that obligation, you get 2 points towards your certification scheme. There are a whole bunch of requirements that you need to meet through this. I won't bore you with the details, but needless to say that our projects and our methodology fit neatly within that. And not only that, but we have created a way in which the evidences that are required by, in this case, the GBCA, are neatly packaged up for you. So all the information that's required to show that, I guess, we're a neat fit is packaged up on your behalf. And that covers off all the manner of monitoring plans through to evidences of the conservation covenants, through ownership of the land, and et cetera, et cetera. A quick example of how that works. Well, let's just say we're in Sydney and we're building a high rise. It's going to be 35,000 square metre build. You might choose to sponsor the Alina project in New South Wales. The credits there happen to be $3 per square metre. And so for the price of $105,000, you'll effectively get your 2 nature stewardship credits. Similarly, if you're upgrading a building from, say, 4 stars to 6 stars, you might go through a similar process. In this case, it's a Melbourne build wanting to support a local Victorian project at $4 per square metre, and the sums are pretty easy to do. Our projects vary between $3 and $10 per credit or per square metre, and that's dependent on where the location of that project is and how much it costs to intensely manage that. We imagine that in time, and we're already speaking to sustainability consultants and developers about their footprints, where their future projects are, and where there's not alignment with our projects, or where there's potential for doing something more sizable and meaningful, we have the ability to be an extension or an arm of your team and your build, where we can go and identify and create new projects with you that meet your requirements. And that's a really exciting, I guess, conversation that we're having now. Historically, I guess, looking at this particular credit type, there's been kind of one option, and that is DIY. Go and buy the land yourself, put it in a land trust, find a conservation organisation, monitor it, pay for it, and etc. It's a very well-meaning but costly exercise, and so this kind of, I guess, takes some of the hassle out of that. We also, I guess, some of the benefits of what we're able to do is we know that we're relatively competitively priced from a credit perspective. Above and beyond that, though, it's the ability to experience this meaningful work. And that's why we were here on Monday. We were hosting some of our partners down at our Coorong Lakes project. We don't want to be bombarded with visits to our project, as you can appreciate. We need to carefully manage that. But the ability to see and the demonstrable impact that the support is having in these communities and in these environments is critical. And not only that, it's the ability to help tell the story, and I'll touch on that in a minute. We've got the ability to turn this around very fast. We've got significant inventory on the 4 projects that we've currently got, as well as mentioned, the ability to turn on new projects that may be based on builds that might be 3, 5, 7 years away. I'll leave it there. Just quickly to say too that, as mentioned, we have a good alignment with the Habitat Exchange imperative within the Living Building Challenge scheme. Very similar requirements. I won't go into the details, but once again, we can provide all the evidences that are required. A couple of examples how we've brought this to life with partners. So I've gotten to know Ken over the last 12 months or so as we've partnered with Lendlease. Our small team works out of an innovation hub that Lendlease developed in Carlton at Melbourne Uni. And about 12 months ago, the sustainability team at Lendlease were running a sustainability summit. And we happened to got word about this, and so we started to talk to them about, well, don't just talk about sustainability, let's do something. So they agreed to protect the equivalent footprint of that particular floor space, which was 5,800 square metres. And we were then able to create for all of the delegates their own 10 square metre batches of protection. So everyone got their own profile and went home with their own meaningful story rather than just your standard kind of tote bag. And then once again, if this was moving, you'd see some pretty cool imagery around how we leveraged augmented reality to help bring some of this to life. So in the foyer of this particular building, we created both videos and imagery and had birds flying around heads and so on. So as you look through phones and iPads, this relatively sterile environment came to life. I guess showing the work that particular event was supporting and sponsoring. And that's the kind of thing that we're able to leverage and build off. We've been talking to Lend-Lease about potential projects and how we could then bring those projects to life. So once again, you can imagine that when construction is occurring on ground, you've got this hoarding that sits around these developments. We could very easily skin that with some incredible imagery from projects that are being supported. We can also create QR codes that then could be scanned, and you could see perhaps videos of what was once here, the ecosystems that were thriving here pre-development or pre-settlement, through to the projects that are now being supported by that build. And we've discussed a number of other ways in which we can, I guess, leverage storytelling to help bring nature into these places and spaces. So I might just leave it there. Thank you for your time. I hope you found it interesting. Very keen to have a chat with anyone who's, I guess, looking at this. And beyond the certification schemes and the like, obviously, we're very keen to be talking to individuals who are passionate about conservation and businesses who are looking at their own nature positive strategies and how programs and projects like ours can support that. So thanks for your time. Thanks, Cam.
Thank you so much, Ash. I've also been I guess like a purveyor of the Living Building Challenge here in Adelaide for a really long time. And one of the things that I think have always been, I guess like a thought leadership for about, almost like 15 years with the Living Building Challenge was this idea of habitat exchange, right? It's like, where can we get this idea that when we do utilize land for development, which is necessary for human habitation, human communities, we also understand that by doing that, we're taking away from our natural sort of environment at times. So where's the incentive to be able to potentially invest or use development as an arm to be able to invest in nature conservation? And it's really appreciated that there's pathways now to that's kind of to scale and with the quality assurance that people and organizations need. So thank you very much for giving us a taste of what Wilderlands is bringing to the market, and also the projects that you guys have sparked and collaborated with on in our state as well. And I know you guys are brimming with the amount of inspiration, but your cup is about to be topped up just a tad bit more from our last presenter, who is Sam Green, who's an associate and senior architect at DAS Studio. We're talking a little bit more of a future of construction, and really appreciate for Sam to be joining us, talking about what they're doing at DAS Studio, looking into, as well as implementing in projects on the go at the moment. So get that fired up for you, and it's for you to take away. Clap.
Cool. Yeah, so very quick look at what may be a future pathway for construction, particularly in South Australia. Thank you for the acknowledgement at the start, Ken. For DAS, I just wanted to extend that acknowledgement to the Larrakia people of Darwin, as we do have a small presence up there, as well as here in Adelaide. And I thought I'd start with a quick intro to DAS Studio, to sort of contextualise some of the projects that we'll go through in a moment. So DAS all started with this one little project being ESCA, which is basically a small-scale tourism initiative. It's basically the little black box dropped in a rural setting as an accommodation pod. What this represented was basically, for the practice, a self-funded experiment in modular construction as a tester for that methodology. And it was sort of about that idea of what happens when you take a prefabricated 5-star hotel room and then drop it in a rural setting. So obviously some amazing experiences come out of that, and a very unique kind of tourism experience. DAS was started by Sarah Horseman there, and then along with husband Dino Virinos. And then we very rapidly grew to what is now a studio of 22 architects, interior designers, and landscape architects. Even before ESCA though, the idea of investigating prefabrication and modular construction as a theme for our practice was sort of predicated by a travelling fellowship study tour that Dino undertook while working in previous practice. So there we are, having sort of all grown up as a practice. I joined DAS at about the sort of 7 people mark, which was the beginning of, about 4 years ago, which was the beginning of a sort of upward growth for the practice. And we work across a variety of different areas. We still do residential projects, and we find that's a great way to kind of cross-pollinate between disciplines. So we try not to sort of isolate ourselves in one bubble or one echo chamber. We try to bring a bit of cross-disciplinary practice throughout every project we do. So that now extends to sort of multi-residential, number of education projects. In recent years, we've started doing landscape projects, and you can see our little studio on the left-hand side there, which is just up the road off Hutt Street. This is a bit of a breakdown of what we've been doing as of 2023. So education's still a big part of it. Landscape, commercial, multi-residential, a couple of projects in the sort of manufacturing and technology space which tie into education that we'll look at later. And then health and institutional, as well as that sort of base of residential where it all started. What we are interested in as a practice, as a sort of overall theme through a lot of the work we do, is how architecture can have an impact at scale. And to that end, a lot of our sort of interest and practice focuses on a number of civic and sort of social infrastructure projects. And part of that process has also been supporting funding and grant applications in the very early stages of the projects. So you can see there are a number of initiatives that we've assisted these organisations with in very early stages, even pre-briefing for the projects. And those have all turned into sort of larger scale projects that have been executed or are being currently executed. A bit of context for looking at future construction methodologies. This is a graph taken out of an Infrastructure SA report. What it shows for SA in particular is a jump in labour demand in coming years. Now we combine that with the sort of skill shortages, which we all know are here now and which will continue. And you can see there's a strong argument for looking at the transformation of the construction industry. A couple of interesting statistics. So the sort of greater construction sector as of last financial year was worth about $3.5 billion in SA. About 1 in 10 Australians are directly employed, and then a number more indirectly employed via the construction sector. Outside of professional services, it's the largest single employer sector in the country. And of course, there's this sort of ongoing underrepresentation of gender diversity in the sector as well. So what this sort of adds up to in our mind is this massive opportunity for shifting the dial on the industry. And part of our practice is looking at how can we do that. So in terms of looking at future methodologies for construction, and a potential future pathway as part of addressing some of those issues. We look at construction as a spectrum, and we started off looking at sort of modular and volumetric construction. In recent years, that's expanded to what we're starting to term smart construction, and that ties into sort of the transformation of industry, the emergence of Industry 4.0, and the digitization of industry. I'll talk to that a little bit more in a couple of the projects that we're looking at. So through the lens of prefabrication, this is a sort of spectrum of different scenarios for different types of prefabricated construction. On the right-hand side, volumetric, which is very much what you saw in that kind of Escapod project, building 95% of a building and then plugging it together. And then shifting to the left through to hybrid approaches where smaller parts might be made up, through to a kit of parts or panelized approach, where elements might be prefabricated then assembled on site, or for example, wall and roof panels might be assembled on site. And then, of course, over to the left, the sort of traditional in situ construction, which we're all probably fairly familiar with. The other overlay to this is, in our practice, we've applied a number of these methods across different settings. But what we've found is that in a very remote setting, and a few of the projects will talk to this, volumetric can be really effective. It can get rid of issues around location loading, so up to a 30 to 40% uplift on construction costs, depending on how far out a project might be from an urban setting. And then as we come back to a more urban setting towards the left-hand side, those other approaches start to become more efficient and more relevant. So this is an example of volumetric construction. This was a project that we completed a couple of years ago for the Royal Flying Doctor Service. This is out at Murray, so about 8 hours drive directly north of here. So a super remote spot. It was basically about replacing an asbestos-ridden health clinic and providing the community of Murray with health facilities which were sort of equal to what we might find in a more urban setting. There's an interesting correlation on a couple of things there. Proportionately, the further out you go from an urban setting, construction costs escalate in the form of regional loading, and also the inability to find trades and skilled labour. The other thing that increases proportionately as you move out from urban settings is actually the health of the population. So this was a nice, neat sort of tie-in to addressing those two things and trying to start to test some solutions to those problems. There's some imagery. This project was basically assembled in 5 parts. And again, it was about providing a health facility that was equal to what might be found in an urban setting in a very remote, isolated setting. So it was built in a shed down at Lonsdale in 5 parts. Those were loaded onto trucks and literally driven up to Murray over a weekend. Once placed, as you can see in that centre image, the building was 95% complete and unloaded and placed over the course of a week. It's a quick QR code. So if you get the presentation later, there's a couple of links to videos and other footage. There's a great little documentary that was made for it as well, which I tear up every time I see, actually. And then in starting to look at this sort of, volumetric model of building, where the majority of the work can be completed in a controlled setting, minimising waste, and minimising sort of wasted effort and resources in the exercise of building on a remote site. We've started to iterate on that with another project at William Creek. So very much thinking back to the frame of mind of sort of automotive design or product design, looking at continual iteration and improvement in every version. from that pilot project, this is the point where I kind of joined DUS at 7 people as an architect. And this is the point at which the practice kind of took off on rapid growth. So we, up on the top left-hand side there is Mitcham Girls' School. We started with a pilot project with the Department for Education a few years ago. That was meant to be a sort of tester for replacing aged transportables, again, asbestos-ridden buildings on school sites. That was very quickly expanded to a larger program of works across these 16 projects and a number of others which were broadened out to the rest of the sort of design and architecture industry, representing an investment in school infrastructure of over $50 million. Out of these projects, these were a great test for modular construction, as most of them were in, within 2 hours of the city, and some were, within an urban setting as well. A number of them remained as modular as a best for project outcome, but a number also, in a typical sense for our practice, in a sort of agile sense, we looked at what's best for projects and went down the path of in situ construction for some of them, based on a balance of cost and program considerations in meeting the critical need for the transition of year 7s in the state. This led us on to another project, which is the Yadu Health Clinic in Ceduna. So Yadu Health is an Aboriginal-owned health corporation. And after several rounds of grant funding applications, this project sort of landed as a project that was a great demonstrator of hybrid construction. So the front third there of the project being built as a kind of civic presence with in situ construction, but then the rear 2/3 being mainly consulting rooms. We're able to sort of modularize those into volumetric construction. Again, addressing those issues around location loading and value for investment in the built environment in more remote locations. So again, finding that best for project balance, where this project really does play a civic role in the community as well. Another example of hybrid construction, so partially volumetric modular and partially in situ construction, was Sione, which was recently completed for Scouts SA up in Piccadilly in the hills. This is basically an activity centre, but also a bushfire refuge. And program was the critical driver for this project. Along the top there, you can see the sort of traditional timeline of construction programming. What we were able to facilitate was a hybrid approach where both construction activities could happen alongside each other. So part of the building being built in situ, while the other parts of the building are being built in a factory, accelerating the program and critically completing the building before the bushfire season started. Now, there were a couple of things to deep dive into in the next section of this, which is about facilitating that sort of overlap of program, which is what a lot of our recent practice has been focusing on. And that brings us to procurement. So again, a sort of traditional linear procurement method along the top. This works really well for in situ construction, but with the sort of smarts that need to be added for that kind of smart construction approach, with a lot more design work up front, a lot more coordination up front, and a lot more manufacturing involvement up front before the traditional tender and construction timelines start. We needed to start looking at alternative procurement methods shown, it's different for each project, and there's a real art to sort of crafting those. But, a version of that is shown along the bottom there, where specialist contractors and manufacturers might be engaged as part of the design team or brought on board to the project early to facilitate design that can be carried through into manufacture. Again, it requires a different team structure. I won't go into it too much given time, but instead of a sort of hierarchical linear structure, we start looking at more collaborative team structures with the certain elements of the team engaged earlier. So that brings us to what are we working on now? This is a sort of $50 million project at Tonsley. So this is a DFE, Tonsley Technical College, combined with the Flinders University Factory of the Future. The Factory of the Future is basically an R&D initiative to drive industrial transformation forward in the state and enable the adoption of Industry 4.0, so the digitalisation of new forms of industry. The Technical College is an endeavour which is sort of addressing that skills gap that we saw at the beginning, but also drives into those sort of future industries that are being investigated in the Factory of the Future. So a great synergy between the two organisations. And of course, we wanted to arrive at something that was demonstrating, a building that was actually demonstrating that approach. So what better than mass timber? Part of the thinking there was around demonstrating sort of design for manufacture and assembly, looking at circular economy principles of disassembly and reuse afterwards, but also looking at a process by which, how do we walk the walk? So this project, unlike many education projects, has committed to a Green Star certification as well as a WELL certification. A couple more images there. So where does this land us as a practice for future opportunities for the construction industry? Our takeaways from these sort of bodies of work have been about process-focused design. So really about considering the impacts of the processes, not only the build outcomes. There's a long history of architecture considering the object. Our focus is starting to shift to people and processes. Mass timber, this was a great experiment there. We've been able to source these from suppliers in South Australia and Australia. Anyone who's interested in mass timber, I'd recommend looking at Timberlink down in Mount Gambier. As of last month, their CLT facility is up and running and able to produce. Transformation of industry, there's a whole lot to unpack there. I'm happy to talk about it after, but digitisation of the construction industry, expanding industry participation and also inclusion, massive opportunities to address those that sort of cliff of skills shortages that is rapidly coming. And then wellbeing, again, looking at the process, people involved in the process, the end users, and also the greater community. And again, doing our best to walk the walk there by committing to a WELL rating for this project, which has had some great influences on design. But my personal takeaway from this last 2 years body of work, particularly with that project, is actually around the impact on people involved in the process. We very much designed for the end users. What I've become much more aware of personally is actually the large number of lives that these projects touch actually through their process of design and construction. I think that's something to be aware of as we start to look at wellbeing as an outcome, but also in process. Cool, thank you.